Hello students, welcome to online maths classroom. This is continuity and differentiability part 2 in which we will solve exercise 5.1 question number 6 to 13. So let us start with it. Question number 6 of your NCERT. Find all points of discontinuity of f where f is defined by 2x plus 3 for x less than equal to 2 and 2x minus 3 for x greater than 2. Okay, you know in such cases we have to check the continuity for x less than 2 also, greater than 2 also, and at x is equal to 2 also. Okay. So case 1, when x is equal to 2, you know I have to check the left right limit and the value of the function at 2, and they all should be equal for it to be continuous. So this is the left hand limit. Okay. At x approaches to 2 from negative side, what do? I put x as 2 minus h. As x approaches to 2 from negative side, h will approach to 0. Similarly, x is equal to 2 plus h. As x approaches to 2 from positive side, h will approach to 0. Okay, this is the function for left hand limit, how it is defined, and this is for the right hand limit. And when I'll evaluate, LHL will come out as 7 and RHL as 1. Since both are not equal, so function is not continuous at x equal to 2. Again, for x less than 2, fx is 2x plus 3, which is a linear polynomial. Hence, it is continuous. Okay, you know a polynomial is always continuous. And for x greater than 2 also, similar case is there. It is a linear polynomial, so it is continuous. Hence, function is continuous everywhere except at 2. So we say that f is continuous for x belonging to R minus singleton set 2. Question number 7. Find all point of discontinuity of f where f is defined by this mod x plus 3 for x less than equal to minus 3, minus 2x for x lying between minus 3 and 3, and 6x plus 2 for x greater than equal to 3. Now where I have to check the continuity? At less than minus 3, okay, at minus 3, between minus 3 and 3, at x equal to 3 we discussed, and for x greater than 3. So for x less than minus 3, you know it is mod x plus 3, okay, that means your, as it is, see, mod function is also continuous, the constant function is also continuous. That way also the sum of two continuous function is continuous, so it is continuous for x less than minus 3. Also, when x is less than minus 3, you can say that it turns out to be as negative time itself, that is minus x plus 3. So it becomes again a linear polynomial. In that way also it is a constant, a continuous function. Okay. X is equal to minus 3, you have to evaluate by using LHL and RHL. So this is how you evaluate for x less than say approaching to minus 3 from negative side. I'll put x as minus 3 minus h. Okay, and this is the defining of the function, and how it comes out when we put the limit h as 0. It is minus 3 mod plus 3. Out of it comes out as 3 plus 3, that is 6. And for the right limit it is minus 3 plus h. X approaches to minus 3 from positive side, h will approach to 0. And in that way we solve by putting h0, we get it as 6. So LHL equal to RHL, and also it is equal to f of minus 3. Okay, so function is continuous at minus 3. Now for x lying between minus 3 and 3, you know fx is your minus 2x, which is a polynomial, hence continuous. When x is 3, now for 3 again you have to check LHL and RHL and the value of the function as it is defined both ways for x equal to 3. So this is how we calculate the LHL, that is put x is 3 minus h, okay, and you'll get it as minus 6, and x is equal to 3 plus h for right hand limit, we get it as sorting out as 20. Okay, both not equal, so function is also not continuous. For x greater than 3, it is again a linear polynomial which is continuous, hence function is everywhere continuous except at 3. So we say f is continuous for x belongs to R minus singleton set 3. Number 8 is your fx is equal to mod x upon x for x not equal to 0, and 0 if x equal to 0. And if you remember the signum function, it is that value. Okay, so you know the signum function gives you the three values only, minus 1, 0 and 1. Okay, so again we have to check the limits at 0, greater than 0, less than 0. Now for x equal to 0, I have to check LHL, RHL and f of 0. Okay, you can also go for your right hand limit only, but you see that I have told you that for modulus, integer functions, greatest integer function, you should go for solving both LHL and RHL. Okay, so when you evaluate the left hand limit, again you have to put x as 0 minus h, so that when x approaches to 0 from negative side, h will approach to 0. And put it here, it becomes a minus h mod upon minus h. So it becomes h upon minus h, that is, both gets cancelled before putting the limit. Okay, otherwise it will become 0 by 0 if you will put it right there. So you have to just cancel all the h first, and then we get minus 1. Similarly, for the right hand side, you get it as 1. Okay, as h upon h is 1. Okay, so again, LHL not equal to RHL, function is not continuous. Okay, don't go for f of 0, as the limits are not existing, so function will not be continuous. When x is less than 0, it is mod x upon x. Okay, so you can either, it is say ratio of a continuous upon continuous function. Okay, that way also, or minus x upon x, that is minus 1, it is again a constant function, it is continuous. Again, for x greater than 0, you can also work it out like this: x upon x, that is 1, is constant function, so continuous. Okay, so x is 0 is the only point of discontinuity, so function is continuous for x belonging to R minus singleton set 0. Number 9 is again x upon mod x. Again, you have to work out, and minus 1 for x greater than equal to 0. So you know this function, how differently it will behave as the previous question. X is 0, x greater than 0, x less than 0, we have to check for all. And for x equal to 0, I will check again the left hand limit, a right hand limit, and that is coming out as minus 1 here. And again, you see, I have from the previous question, we have defined this same as for right hand limit, say the result is minus 1 here. Okay, so in that way, both the values are same, and f of 0 is also same. Okay, so function will behave continuous. Okay, minus 3, it is continuous. For x less than 0, again, it's the ratio of two continuous function, or again x upon minus x, that is minus 1, is a constant one, again continuous. Similarly, for x greater than 0, it is again a continuous function. So this function is behaving continuous for our real. Number 10 says, find all point of discontinuity for f defined by x plus 1, x greater than equal to 1, and x square plus 1 for x less than 1. So again, I have to check the continuity at x less than 1, okay, greater than 1, and at 1. And for at 1, you have both defined ways. Okay, so you have to go by the method of LHL and RHL. So when x is less than 1, you know the function is simply defined as a quadratic polynomial x square plus 1, which is everywhere continuous, hence this is continuous. Okay, and when x is equal to 1, again you have to go by LHL and RHL. So the left hand limit is turning out to be, put x is equal to 1 minus h, as x approaches to 1 from negative side, h will approach to 0. For right, put x equal to 1 plus h, as x approaches to 1 from positive side, h will approach to 0. And when I'll put the limits, okay, and again, there's no need to open it. You simply put h0, you'll get it as 2, this is as 2, and f of 1 is again 2. So both, all of them are equal, so function becomes continuous at x equal to 1. When x is greater than 1, again it's a linear polynomial, hence it is continuous. So again, this function is behaving continuous wheresoever it is defined, and again at for greater than 1 and less than 1 also. So function is everywhere continuous. Number 11 is again find all points of discontinuity for this function, x cube minus 3 for x less than equal to 2, and x square plus 1 at x greater than 2. So I have to check the continuity for x less than 2, equal to 2, and greater than 2. For x less than 2, it's a cubic polynomial. Okay, so again continuous. For x equal to 2, I'll go by LHL, RHL, and f of 2 because it is defined. So for x approaches to negative side, I'll put x as 2 minus h. As x approaches to 2 from negative side, h will approach to 0. Similarly, for second one, x approaches to 2 from positive side, put x equal to 2 plus h. As x approaches to 2 from positive side, h will approach to 0. And put wheresoever the function is defined, okay, 2 minus h whole cube, no need to open it, simply put h0, you'll get the result as 5. This way also you'll get the result as 5, simply put h0 here, and you will just solve the rest, and f of 2 is also 5, so function is continuous at x equal to 2. For again x greater than 2, it's a quadratic polynomial which is continuous, so this function is also behaving continuous for all real numbers, and there is no point of discontinuity. Number 12, x raised to power 10 minus 1 for x less than equal to 1, and x square as x greater than 1. Again, for need to check for less than 1, greater than 1, and at 1. So for x less than 1, it's a x raised to power 10 minus 1 is a polynomial function, is continuous. Okay. For x equal to 1, I have to go by LHL, RHL and f of 1. Okay. So for left hand limit, you know, it is defined like this. For RHL, it is defined like this. Okay. And for left hand limit, we need to put x as 1 minus h, so that as x approaches to 1 from negative side, h will approach to 0. So see, it is 1 minus x raised to power 10 minus 1. So 1 minus h raised to power 10 minus 1. Put h as 0, you get the value 0. For RHL, it was x square, so it will be 1 plus h whole square, which is 1. So limits are not equal, function will not be continuous. Okay. And for x greater than 1, it is a quadratic polynomial. Okay. So is continuous. Okay, so this function is behaving continuous except at 1. So we say function is continuous at all x belonging to R minus this singleton set 1. Again, number 13 is the function defined by x plus 5x less than equal to 1, x minus 5, x greater than 1 is behaving continuous or not. So again, I will check the continuity at x less than 1, greater than 1 and at x equal to 1. Okay, so what is happening at x less than 1? It's a linear polynomial, is continuous. Okay, no problem. For x equal to 1, I'll check LHL, RHL and f of 1. So the LHL says I'll put x as 1 minus h. As x approaches to 1 from negative side, h will approach to 0. Okay, I'll put the value in place of x plus 5. I'll put 1 minus h plus 5, put h 0, apply the limit and we get 6. Again, for the right hand side, it was x minus 5. So it is 1 plus h minus 5. Put h 0, I'll get as minus 5. As the limits not equal, so function is not continuous. Okay, and for x greater than 1, it's a quadratic polynomial, again continuous. Okay, so f has only one point of discontinuity, that is at x equal to 1. So how do we conclude that f is continuous at all real numbers except at 1? That is, f is continuous at x belonging to R minus singleton set 1. So this is how we check the continuity of the functions at all points. Okay, wheresoever it is defined, and at the points it is means for less than values, for greater than values, and at the values where it is defined in two different ways, or you have to check the continuity at particular point. So you get all the values that wheresoever function is behaving continuous. Okay, and in this way you can check the discontinuity if it is existing at a particular point. Okay.